Swayam Prabha. Digital India. Educated India.
In this presentation, I will quickly, since we are running late, short of time also, I will quickly go through why it is important to do life cycle assessment in the solid waste management sector, and also why it is important to develop life cycle inventory, emission inventory related to these sectors. Many developed countries have already developed their own specific country-specific emission factors, emission metrics already. We are still lagging in those areas. So here you can see the municipal solid waste itself is contributing at around 10 to 11% of global anthropogenic GHG emissions. So, and also if you look at the share of total emissions between developing and developed countries, the developing countries emissions is shooting up like anything. So, and this is like why the waste sector matters most. So it's mainly because of there is lot of methane emission associated to different waste treatment technologies, waste management facilities. 2 days back, I think you were asking about like why we are not considering the biogenic carbon dioxide. Yes, we are not considering biogenic carbon dioxide, but methane we cannot exclude from, since that is also emissions associated to some like organic matter which is already in the carbon cycle, but it has huge impact on the environment, about 27.2 times intensity it will warm the whole planet in 100-year duration, and if you come to shorter terms it is much intense. So how to mitigate? So methane capture, carbon capture, flaring, the diversion of degradables to specific treatment facilities. These are the methods we have already. Researchers are already been working in this domain from many years, and already many technologies have been developed so far so that we know everything about which technology should be used for what type of waste, but still we are lagging. I will come to that in the coming slides. So this is the like where India is standing, and from government point of view, they are also working hard, making new policies. Sometimes it works. There are a lot of trade-offs between different aspects: economic, technology, social acceptance, all these things. So this already, I think everyone would know the fate flow of the solid waste from waste generation to disposal. I think in order to exercise that EQT tool. So in this presentation, I will cover this and also introduce one tool, that is EQT, which is developed by IGES. And it is important to know how the waste is managed in the cities. So, okay, there are different technologies that also we might have studied in our course, like what are the different technologies. Also, there are different research going on, new technologies. But these are some of the major technologies that are already in use. And you can name also different new technologies also coming up. But are they really sustainable? So by just simply saying one aspect, taking one aspect of any technology, we cannot say this is sustainable or this is not sustainable. Like in the previous lecture also, sir was saying from a like company point of view, they want their company to be sustainable. That doesn't ensure that the whole process is sustainable for environment, or it is useful for the public. So are they sustainable economically, technically also? So you will see in like research area, you will see many research that are going on, but you will find that yeah, it can solve the whole problem, but that may not be in technology readiness level. We would need much more infrastructure to make it more popular or make it work in a larger system or scaled up systems. So socially acceptance, so many people are not aware of different technologies that are coming up, or already there are many there is opposition to different technologies due to some like NIMBY syndrome. All these things are will affect. And is it sustainable environmental? So as part of this this talk, we will mostly talking about how to use this IGS EQT tool. So we will be only considering whether any technology is environmentally sustainable. So in this tool, there is no option for economic analysis or techno-economic assessment. So here in the previous presentations also by Professor Su or Professor Indumati ma'am, we have talked about different technologies and what are the emissions associated to different technologies. So we all already know these things, like open dumps will, it is associated to high CH4 emissions, then leachate issues are there. Engineered landfill have gas, engineered landfill having methane recovery system will lower the CH4 emissions, but there will be CO2 emissions from flaring. Composting will have fugitive CO2 biogenic emissions, then avoided CH4 credits. All these things are there, and this is like an example of how to reduce the emissions associated with the waste. So verbally we can take like these are, everyone knows about this, but how we will put these things in unless we put numbers associated to it, we cannot prove or we cannot move forward with these insights. So in order to do that, LCA studies are very important. Life cycle assessment of these technologies will only give how much we will improve on different sectors of the technology. So for that, we should evaluate these systems individually and as a whole also, then we will evolve, and that's a continuous process. So in order to do the LCA, we have like protocols, different protocols, and this is a like very common typical framework for LCA study. You will get to know more about this in this. And also this is one's framework for the whole solid waste management system in any city. So this we have taken as a system boundary for the fresh municipal solid waste management system. So these are some of the different types of waste composition and where it should be taken. Like for example, organics should be taken to composting and aerobic digestion. The rejects from that will move to waste to energy plants, and the dry waste will go to RDF, or some of the inert waste will go to landfills. So this is like typical system boundary for MSW framework. And for this project also, and in the IGS EQT platform, we are only talking about the operation, the life cycle assessment associated to operation of these facilities. Construction of these facilities or decommissioning or deconstruction of these facilities are not accounted for. So there are different models available in order to calculate the GHG emissions. These are some of the available models. You can see IPCC model, then GHG calculator for solid waste sector developed by IGES, solid waste management GHG calculator. You can go through or you can explore these different types of models, but we will be talking more about the GHG calculator, which is developed by IGES. It was issued firstly in 2013, but we will be working on the latest version, which is 2013 version 3, 2025 version 3. So this is the emission quantification tool. It's a Excel based tool. So I will give one quick how to use user guidelines to use this tool, and at the end we will try to do one exercise where you will be the mayor of Chennai city, and you will have to make the Chennai solid waste management system more efficient. So So in the app, we will be giving data in terms of consumption of fossil fuels or consumption of fuels associated to different activities associated to the waste management facilities, like starting from transportation, collection of the waste from household to transfer stations, then composting, anaerobic digestion, all other treatment facilities. And also we will account the avoided emissions in terms of the products that we are getting from different, for example, biogas from anaerobic digestion facilities will be offset to restaurants or fuel stations. Those kind of avoided emissions we will account, just like we do in LC analysis. It will enable us to calculate the GHG emissions if we input these values. So this says the hierarchical importance of accuracy of the data. So most important accuracy should be given to composition of generated waste, amount of waste used for different treatment options. So this is the user interface if you go to the IGS EQT platform. So in the folder shared with you, we now have shared this EQT platform in the folder. Just a minute, I will get to that. I will give one just brief about how to use this thing. So in the Excel file, you will see many green cells. So in these are where you should put your data. These are the places you should input data. That is required user input. Then there will be some default values. For example, emission factors associated to burning of fossil fuels, emission factors associated to CNG, or emission factors associated to fugitive emissions from composting facility. Those kind of values are already assigned, already defined by IPCC. It is taken from the basis of IPCC 6th amendment. So those values will be given, and you cannot edit or change those values. And then there will be emission results. At the end, you will get your results. And some places you will see these notes and references. It's kind of help. You can see what they are actually looking for you to input the data. So this is also like, so in this task also, in this exercise, we will be giving Chennai waste management data, and in the business as usual column, you can input those data. And we have included some scenarios as well. So there are 4 scenarios, but for the time being, we will divide you all into 4 groups, and we will try to do one scenario after the other. Okay, so here you can see some help notes or references that is related to different cells. So basically you have to add waste generation data, composition data, and transportation associated, like how much fuel you are consuming, and operation, like different treatment operations associated energy consumption data, those kind of data. It is very simple to use, but you will have to go through different, I will tell you about, like when you start the this Excel sheet, first thing you will find will be key data, where you will input general data about city, like name of the city, total waste generation, population, all those data. Then you will move to transportation sheet, then composting sheet, AD sheet. For the time being, we will not include recycling, RDF or MBT technologies. Then there will be incineration sheet, landfilling, or open landfilling we will use. And so ma'am was also saying about the, like generally how much waste is generated in Chennai. So those kind of like general waste profile of Chennai city is also provided in the shared folder. You can look at that. I think you will not see in some of the files, you will not see the units, but you can come back here and check the units. And you can also work yourself, if you want to change some data, and you can collect some data from the net, or you can assume many data also. The idea is to perform the or do the exercise in order to get acquainted with the GHG emission tool, and also you can explore more going back to your place, and then you can find GHG emissions associated to your cities, and you can play with the this tool basically. So I think now you can open the shared folder and use, you can see this. This is a map showing like what are the different types of solid waste management plants that we have. We have composting facilities, some micro composting facilities, not major like pilot scale composting facilities are not there. Only 100 TPD composting plant is there in Madhavaram. And then there are two biogas plants of 100 TPD capacity, one in Chetpet and one in Madhavaram. And then landfill sites are there, like Kodungayur landfill is a major landfill here. So this is a what are the current waste management practices in Chennai region. So what are the vehicle fleet that we use? Battery operated vehicles are there for house to door collection. Then big competitors, majorly they use diesel as fuel. So as we move forward, we can see like this is the composition of waste for the Chennai region. This also you can input. I think these data are already provided in the some waste profile. Are you able to find the Excel file? I think you, yeah, I think two of you can work together. Like in each bench you can work as a single project, and each column, I mean this side will work on scenario 1, and this row can work on scenario 2, this row can work on scenario 3 and scenario 4. But later on you can work every scenario as you like, but we won't get that much time for adding this many data into the app as of now. So I will explain these scenarios a little bit. You can check the, meanwhile you can check the Excel sheet EQT. So scenario 1 is where the all solid waste that is generated in the city goes to landfill, where there is no methane capture. Gas LFGs are not captured. And scenario 2 is methane mitigation push. So we are enabling the landfills with methane capture technology. So in this scenario 2, there will be all the waste is still going to landfills, but the landfills will have methane capture. Okay, so in scenario 3, we are pushing for waste to energy plants. So incineration will be a major technology here in scenario 3. So in scenario 3, we will increase the incineration capacity 30%. So 30% of the waste is diverted from landfill to incineration plants. And also we are pushing recycling also. 20% of the waste will go to recycling. So about 50% of the waste that was previously going to landfill is now diverted to incineration plants. And in scenario 4, giving an organic diversion drive. The organic fraction of MSW is reallocated. So as I said, gas plants of 100 TPD. So currently the if you organic fraction of MSW, it will come to a TPD. And so the organic fraction will go to will minimize organic fraction CH4 generation. You can see different sheets here. This is the home page. Some introduction about the tool, how they developed it. The first major sheet that we, as I said, these are green cells. You cannot change any other cells. So the first portion of this, so once you enter the key data in this sheet, you can move to transportation. Here also you can initially input the data regarding business as usual. So what are the trucks that we use? From drop down, here you can select. So these blue cells are results actually, so don't worry about the blue cells. And then these are some of the emission factors that they have taken from IPCC. So here also you cannot enter anything or edit anything. These are basically the calculation behind that particular or corresponding processes. So your aim is to enter data here and find like what it will bring to the result.